Sanders Mathematicians. This come to you another video. We are still in the packet B rational quotients of integers, but we are now activity 2.1. So let's read. Decimals can be classified into two categories, terminating and non-terminating. A terminating decimal, it has a finite number of digits. So it means that after the finite number of decimal places, all the following places have a value of 0. Terminating decimals are rational numbers. So what does that mean? It means that like they stop. We can keep dividing, but they're going to stop at some point. So they terminate, like the Terminator. He eliminates you. Think about it like that. Non-terminating decimal is a decimal that continues on infinitely without ending. It just goes on and on. It's like the song that doesn't end. Yes, it goes on and on, my friend. You probably ain't know nothing about that. That was back in my day. If your parents listening, they know about that. But anyway, number 1, we're going to classify the decimals in question 1. Question 1, which was in our getting started. Are you a terminator? As terminating or non-terminating? We kind of started doing that because I pre-taught this before I recorded this video. So we know number 1 and number 2, whether it was terminating or non-terminating. But 3 and 4, you should put it on this paper. Classify them. Were they terminating? Did they end when you divided them, or did they keep going? Okay. Number 2, determine which unit fractions are terminating and which are non-terminating. Explain your reasoning for each. So here we go. We have all these wonderful fractions here. Some of them you should know by heart. I know some of them by heart. Not because I'm the teacher, but because I know them. And if I know them, you should know them. So let's circle some ones that you should know by heart. You should know 1/2. You should know 1/4. You should know I know, but maybe 1/5, maybe 1/10, and possibly 1/3. Possibly 1/3. I think these are the ones that should be obvious. If you don't know them, guess what? It's okay. You can figure it out because you can divide to figure out any decimal for any fraction, which is what we do when we do our data analysis. So you can figure them out, but you should know 1/2 is 0.05. You should know that. These are benchmarks. Remember it. Take a moment. Put it in your brain. 1/2, 0.5, 1/2, 0.5, not 50, 0.5, 1/2. Take a moment. Okay. 1/4. You should take a moment to know that one. It's 0.25. It's a quarter. It's a quarter. Take a moment. You should know that. Right there. The fifth. The fifth is 0.20. 20, 40, 60, 80, 100. 5, 20, 40, 60, 80, 100. Yep. That's what we should know. And a tenth. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. A tenth. 0.10. Okay. The third, maybe. But if you do know 0.33333, because we've done so many data analysis and we've had thirds and we've had to do 0.333 or 33%, 66%, or 100%. But hey, if you got it, you got it. If you don't, memorize it. Take a moment. And how do you do all these? You divide. Top in, bottom out. Now, 1, 6, 1, 7, 1, 8, and 1, 9. But I do not expect you to know. But I do expect you to figure it out because we are in 7th grade and we have to change fractions to decimals. And you saw that in your district quarterly assessment. They had so many fractions that you had to figure out as a decimal or the answer was in decimal. So this is the time. Practice. We practice for the marathon, for what we're going to actually do. And this is the time to practice. So what I want you to do. So I want you to divide your paper into 4 pieces. And this is going to be your 1/6 piece. This is going to be a 1/7 section. This is 1/8 section and 1/9 section. And you are going to divide all of these. And then you're going to figure out, are they terminating? or non-terminating? Do they stop? Or do they keep going? What do they do? All right. I can't wait to see your answers. Now, non-terminating decimals can be further divided into two categories, repeating and non-repeating. So we terminate and we non-terminate. Now we can repeat or non-repeat. A repeating decimal is a decimal in which the digit or a group of digits repeat infinitely, just like that 4, 5, 4, 5, 4, 5. Remember that? This was going to keep repeating forever and ever. 4, 5, 4, 5, 4, 5. Yes, it was. Bar notation, when it does repeat, what we do is we put a bar over it. I don't know if you noticed that in the one. Because I knew it was going to go on forever with the 4, 5, I just put the 4, 5 with the bar. Because that tells me it's going to keep going. Keep going with the 4, 5, 4, 5, 4, 5. See the beat? 4, 5, 4, 5. It's going to keep going. A non-repeating decimal continues without terminating and without repeating a sequence of digits. Non-repeating decimals are not rational numbers. They're not. Because they have this random thing like pi. Pi have this random, y'all remember pi? You better know pi. Because pi, we got to calculate circles with pi. So pi is this like number that's like 3.1428 something, 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 something. Random numbers keeps going. This is a non-repeating decimal. It keeps going. Nobody knows what they are. It's just, it don't repeat. But it keeps going. Keeps going. All right. And that's called an irrational number, but you don't need that till 8th grade. Number 3. So we're going to classify non-terminating decimals in question 1 as repeating or non-repeating. So now we're here. We're back on this question 1. Are you a terminator? Boom. Okay. And I already gave you the first 2. So you know, number 2 is repeating. Figure out, is number 1 is it non-repeating? Or is it repeating? And then you figured out number 3 and 4 because you divided it. So I want you to put that number 1, number 2, number 3, and number 4. And we already know number 2 is repeating because it was 0.45 over and over. So you need to tell me number 1, number 3, and number 4. And then the last one, use your results in question 2 to make a conjecture about other fractions. Which fractions will have repeating decimal representations? Use examples to support this conjecture. So I know these are some big words, y'all. These are some big old words. But what I just need you to do is look at number 2, which is just right here, and kind of see like if there's a pattern. What numbers do you think have repeating, non-repeating? Do you see like if their denominators are causing them to repeat or not repeat? I just want to see what you think about that. So like in 1/2, we know it's 0.5. 0.5, it ends, it terminates, it does not repeat at all. 1/4, it ends, it doesn't repeat, it doesn't turn, it's terminating. Same with 1/5, same with 1/10. But we know some of these other ones, which you have to figure out on your own, of course. They have some special patterns. So I want you to talk about that here in number 4. Talk about the patterns in number 4. And you can put them in the categories. You can say which ones have repeating, which ones have non-repeating. Talk about it. I'll see you in the next video.